Wonderful. All right. So the plan for the day today, we are going to go over the examples that we didn't quite get done yesterday. We're going to do a few more trig notes for my friends who are just learning trigonometry. We're going to do some more homework examples. We're going to just do a few more examples. This is what we've got. I did change the homework assignment for tonight. So if you were working ahead because you're awesome like that and that was your thing, let me know and we'll make adjustments. Otherwise, just to be clear, you can't see that yet. Oop. Well, that's not what we wanted. Hold on just a second. Go back. Physics. Down at the bottom in the Unit 2 calendar, that's where the assignment is. So we are down at the bottom here. So this was the one that we did for today. Tomorrow, it's going to be 21, 24, and 25 from page 112. And then we'll move on. The other reason that I wanted to pull this up for you is to make you aware of the fact that we are getting close to another quiz, okay, to the end of this unit. This is a pretty quick unit. There are only 2 big sections. So we'll probably quiz, I would say, Friday, Monday. We'll see how things are going the rest of this week, okay? But just be aware that that's kind of where we're at. That's why I want to make sure that you get your other quiz taken care of, any extras that you want to do for that ahead of time. Otherwise, you're just going to get yourself behind and like it just snowballs and it does not help. Okay? Questions about logistics? Okay, we're going to jump in and get started. So you can go ahead and pull your notes out from yesterday. You will need a calculator today. You may want to have that equation sheet out as well because it does. I don't know if I pointed out to you yesterday that the sine, cosine, and tangent business that we're going to define is on here. So if you are not familiar with the trigonometric functions, they are on your sheet right there for you, okay? So yesterday, when we finished our conversation, we had drawn this picture, but we had not solved it. Am I correct? Is this where we were in this class?
Yes.
Okay, fantastic. And we were like anticipating this, so excited. So I'm imagining that many of you were in your dreams, like trying to figure out how to figure this out. Maybe, maybe not. If you weren't, we're going to do it now. So everybody's attention is up here. Yes, you're going to need to know this. Yes, this is going to be on the quiz that you do at the end of this week or early next week. Beaker walked 4 meters north, 6 meters east, and finally 12 meters south. What was his displacement? Again, if I don't know if I mentioned this before, really what this means is if I start off at the same place, this is the starting line, and I don't want to walk this long distance, where could I walk one direct path to find him? Okay? Do you remember what this blue vector is called? It starts with an R. The resultant. It is the result of all of the other vectors, okay? Resultant means the result, okay? So what is his displacement? I want to know the blue vector. So there are lots of ways we can do this, but I'm going to try and teach you the easiest one. There are an infinite number of paths that I can walk. One is this blue path. Another one would be to walk over and then down. The nice thing about the over and down path is it's a nice right triangle. So let's draw that triangle. You can go ahead and draw it on your paper. I'm going to draw it on my paper with some highlighter so that you can see it really well, assuming that my stylus works. So I'm going to go over, and I'm going to go down, maybe. Come on, there it goes. Okay. And that vector path will get me to my resultant as well. I like that vector path because it's a nice right triangle. In this case, nice is really true, but really what I'm just looking for is a right triangle. I'm going to go ahead and mark the right angle so that I don't get myself confused. And I'm going to figure out how long each of my legs is of this triangle. How far is this distance right here, ladies and gentlemen? 6? It's got to be 6, right? It's parallel to that orange one. It's got to be 6. So we've got a 6-meter side on this one. I'm going to move this 12 meters that was marked there because I don't want it to be confusing to you. So I'm going to make this the 12 meters there. But then I've got this other little piece right here, this side of my triangle. And how big is that side of my triangle? 12 minus 4, what Jordan tells me is 8. You with me there? Is that okay? So I've got a side that's 6 and a side that's 8. And then I can use the Pythagorean Theorem, Or I can use my nice 3, 4, 5 right triangle on this one in particular to tell the length of this side. Shall we go through the Pythagorean theorem there? Would that be helpful? Yeah? Go ahead, hon.
Okay, so why is the 12 meters so, it doesn't look much bigger than the 4 meters?
Because the 12 meters is actually this whole thing. Are you with me there? So when I originally drew it, that green line, it was that really long one. Okay. I just moved the number up there so it wasn't confusing from this one. Okay. Yeah, that works? Mm-hmm. Okay. All right. So let's go. Yes, you would like me to go through the Pythagorean theorem? Yes or no? Yeah, let's do it. All right. So Pythagorean theorem, remember we talked about this yesterday, is a squared plus b squared equals c squared, where c has to be the hypotenuse. That's the thing we're looking for. I'm going to call that, I don't know, what do we want to call that? We'll just call that the displacement. That's what we want, okay? Or we can call it c. A squared is 6, so 6 squared plus 8 squared equals the displacement squared. How do I get d all by itself? Right now it's squared. How do you undo squared? Square root, right? So I'm going to take the square root of both sides. The square and the square root go away, so I've got d is equal to, you can either do this in your head or you can do this on a calculator. 6 squared is 36. 8 squared is 64. The numbers add up really nicely. 36 plus 64 is 100. The square root of 100 is 10. So 10 meters is D. How are we doing so far? Yeah.
So what if on the test, so what if you don't know north, east, south? So what if you put 4 where the 6 is? Would that mess up the whole problem?
It would, yes. So we need to make sure we know our cardinal direction. So let's write them down right now. Does that sound good? So if you write down a little, it's basically just a axis, right? Up is going to be north, right?
Oh, it's just normal. Okay.
And then down is going to be south. And I don't mean that in a bad way, right? But yeah, you're exactly right. It is going to be normal. East is over here and west is over here. There's nothing big and scary about that.
Oh, yeah, I knew that. I just
didn't
know if it would matter, like where you're sitting. I don't know.
So it kind of does and it kind of doesn't. We're going to do a bunch more problems and I think it'll help. But let me know if it's still confusing. Does that sound fair? Cool. All right. So now it asks for the displacement. And this is the point at which we need to think carefully. Because yesterday, I asked you 4 questions that were like a little quiz, right? And the first of them, what is the difference between a vector and a scalar? And we said that a vector has to have what and what? Direction and size or magnitude, right? The 10 meters is a size. Displacement needs to be a vector, so it has to also have what? It also has to have a direction. So you may want to just put a box around that and say it's done, but actually it's not. Because we need to say in what direction. Otherwise, you're just saying that Beaker walked 10 meters, or he's 10 meters from his starting point. But how many places are 10 meters from his starting point? How many different places are there?
360. Right?
An infinite number of them, right?
Yes, lots.
A lot. Yeah, because you go, right? We want the spot where he is. The specific spot where he is. So what are we going to do? Yeah.
Are we gonna
say that again?
Are we gonna look at the direction thing?
We are going to look at the direction. So we can use the north, south, east, and west to help describe it, right? So it looks like he's pointed in this direction, in the southeast direction. You with me there? But I could say southeast, and then I still have an infinite number of points, right? A smaller number of infinite, but still an infinite number of points between east and south that he could be. I want to know the exact spot. So not only do I need to use the south and the east, but I also need to find the angle. And this right here, my friends, is where the trigonometry comes in handy. Okay? So you're going to mark the